Okay, now that this is working, and do give me a thumbs up when you start hearing me. All right, today the title of my talk today is How to Give a Talk That Everyone Will Remember. And my name is Tony Saad. I'm professor in chemical engineering at the University of Utah. That's just plain wrong. That's not how you would start a talk. Why would you read your title? Everyone can read. We're not here to listen to you read your title. We're here to listen to some insight about what is behind that title of yours. So instead of reading your title, I recommend do one of the following. Pose a question. For example, for this talk, I would say, have you ever wondered how to give a talk that leaves everyone wanting? Or have you ever wondered how to give a memorable talk? Right? Because these are questions that resonate in everyone's mind, but they typically don't want to ask them, except maybe in private or when they're Googling, right? Or here's another example from our work. Have you ever asked yourself how you can apply CFD for public health applications? So that's the title. That's how I would start my Abravanel Hall talk, for example. Okay, it will keep the people like, yeah, this is interesting. I want to see what they did in this research. Tell a story. You can start by saying, for example, for this talk, I would start, today, I want to share with you some of the strategies that I use to build effective and memorable talks. Or, I'm very excited to tell you the story of how we helped the Utah Symphony understand COVID-19 risk. Or, good morning. What I will share with you today is an unexpected result when using drones to measure air pollution. It adds an element of suspense, which I will talk about later. It adds an element of being yourself and genuine, because these are the types of conversations you have with people, with friends on the bus, etc. You ask questions, you converse, you discuss. We are here to listen to you because it's you. We're not here to listen to you read your research paper. Okay? All right. So next, I'm gonna ask you to actually pull a pen and paper and pose a question related to your research. Okay? I'm going to give you 3 minutes. Think of it this way, like your next talk that you're planning, you have a certain title in mind. Instead of that title, I want you to ask a question related to that title, as if you are starting your actual talk. Please pull a pen and paper or your notes and go ahead and start writing some examples down. We will discuss those at the end of the lecture. All right, that was time for me. So now that I hope you've written posed your research question, we're going to talk about it at the end of this talk. Next, I'm going to talk to you about the outline of this talk. We're going to start with an introduction, then we're going to identify our audience. We're going to plan the content accordingly and tell the story and then give some examples and finish with some conclusions. Now, you know what's going to happen next. What's the next slide? This is wrong. When you're telling a story, you don't tell people what's in that story. Maybe some chapter titles, but there's a better way of doing a boring outline. To me, when I see an outline, I see someone wasting my precious time listening to them by showing me an outline. That's 30 seconds or 1 minute spending on a silly outline. I want you to engage me with the story. I don't want to read an outline. So instead of an outline, here's what I suggest. Do a punchline. Think of the outline as a learning objective of your talk. And that learning objective is what I will get out of this talk. Let me give you. Today, you will learn tips and techniques about how to posture yourself, how to pace yourself, and how to build memorable presentations. That's an actionable, measurable learning objective. And it's an outline, it does it in a second. Or in the next 30 minutes, I will tell you the story of how we created a new algorithm for fluid flow simulations that is 40% cheaper than conventional methods. So now what I've laid out, I laid out the outline. I'm going to explain to them, I'm going to explain to you an algorithm. There's fluid flow simulations involved, and there is a product that you get in the end, the 40% cheaper than conventional methods. Okay? So now I hope that you will also have an idea of what's going to come in next. You're going to, again, pull up a pen and paper and come up with a punchline about your research. Think of this about your next presentation. Just humor me. Pull a pen and paper or your notes and write a punchline, just like I did. Okay? I'll keep the previous slide up for you so that you can be inspired. Okay, I'll give you 3 minutes. I want to see you writing and moving. I can see you on Zoom. So I want to see you writing, typing. Okay. You have about a minute left. All right, I'm calling time right now. I hope you got some of that typed up, and we can discuss at the end when we switch to Zoom. But now I'm going to continue with my talk, and I'm going to now step back for a second and give you my perspective on public speaking. And this was primarily motivated by our recent gig with the Utah Symphony. And I've always been inspired by some of the greatest speakers in the world, such as Steve Jobs primarily. And I know Steve Jobs is in business, but take, for example, other speakers that come to the School of Law, for example, or some of the other colleges on campus. They stand in front of you, they don't have any slides, they don't have any equation, and they sit and they deliver some of the best talks filled with a lot of reasoning and thought processes, and it gives you room for your imagination. And I always thought that in science, we never had that kind of training on how we should deliver our talks. There's a sense that if you do a fun and exciting edutainment, so educationally entertaining talk, that you are not serious about your research, that you need to go by this and that, and if we look at the hyperconfluent geometric function over here, if it circles back to this, I think this is nonsense. Okay, I'm not saying you go and you're doing a sales pitch, which in the end you are kind of doing a sales pitch about your work. That's in the end what proposal writing is about. We're selling our research ideas to these reviewers, no matter how great they are. This is the way how you phrase it and how you sell it. So my hope in these next few slides is to summarize how I reasoned about my approach to public speaking. And certainly, I'm not the best public speaker on earth. I stutter, I use and I use a lot of slang. English is not even it's my third language. And so, there's a lot that I have to learn. But, with the few successful speeches I had, I wrote down what I learned, and I'm going to share those with you. So every speech, every talk you give is essentially a story. And us humans are unique among the species in that we are the only species that tells stories. Have you ever seen two birds talking to each other and telling each other what they saw at the river and chit-chatting and telling, they might come and tell others in their family, look, there's food over there, follow us, but there's no storytelling, there's no fiction, and there's no stories about facts and telling about what happened. It's only restricted for humans. The first thing that a child does and is obsessed with is storytelling. Even my 9 months old baby now, he grabs these books that we have for him just to look and see what's coming next. There's this element of suspense. So now we're going to take that story and model our talks according to storytelling, fundamental storytelling. Every story has 5 elements in it. The first one is characters. That's character development. We're going to talk about that. Next is the setting of the story. Where is the story taking place, and how we're going to translate that to research. There's conflict in every story. Now, there's a problem. That's the problem that we're trying to solve. There's a plot. This is essentially what happened in the story. There are plot twists. We'll talk about those. And then there's finally the conflict resolution. Now, if you cannot see this, how this translates to research, let me help you. Characters is you and the graduate students who worked on the work. And it's primarily you when you're giving the talk. Setting could be the methods or the techniques that you used or the content of your slides, really, because you're telling the story in your slides. Conflict is the problem that you're trying to solve. Plot is the methods and techniques that you used. We used CFD, we used hyperconfluent geometric functions, or we used principal component analysis, etc. And the resolution is what you discovered and what you're here to share with us. All right, we'll start with character development. This is really just you, okay? Maybe you can talk about the students that are involved, but since you're telling the story and you're leading the research, this is about you. And in your talk, the first 10 seconds, 30 seconds, I'm coming up with these numbers, okay? But you gotta engage the audience. You gotta develop your character in the first 10 seconds. so that they know what they're dealing with. You don't want to be boring. You don't want to be mean. You want to be fun. It's okay to be shy, even. Okay, it's okay to be. Think of this. One of the talks I remember in my entire life is a talk by a grad student at the AICHE conference in San Francisco in 2017. And the kid was a nervous wreck, and he had a fever. I think he was running like the flu or like I don't know, he caught some really bad bug. And he stood up. He was like sweating more than Anthony Weiner at a press conference. And he was like shaking and standing and trying to talk. And we loved him. We loved him. Everyone was cheering him up. Why? Because he was genuine. He stood up. He we knew he was scared and he was fearful and he was sick on top of that. So he was genuine. People love genuine people. Okay? Don't try to be someone you're not. Okay? If you're fun, reflect that. If you are shy, you can reflect that, but you gotta get over it. And I have a tip for you. But don't try to be someone you're not. I mean, we spend our entire lives telling us be who you are, be who you are. Now, of course, there are rough edges that you need to work on to be better at, but in general, you gotta build around who you are. That's your uniqueness. That's why you can tell you a story like no one else can tell. Now, if you are shy, you better rehearse. Otherwise, this is going to be a rough journey for you, okay? Because you're going to be in our work, we're going to have to talk and discuss and talk and present. Okay, you might find research positions where you're not obliged to talk, but those are going to be hard to find. One thing that helped me, and for those who know me, I love attention, and that is because of my sister. She's an attention hog, and she knew I was very shy when I was a child. I was extremely shy and bullied to from here to Jupiter. Okay, and I was short, and I ended up being taller than my friends, but that was like way when I was 18. But at the time, everyone was bullying me, and I was good at school, and everyone criticized me for that, and I was shy. So what she did, she put me in the church. I read the letter every week. I went to Catholic school, and we had mass every week, every Monday morning, and I read the letters there. And even when I remember one time I had a fever, and she said, you are going to go and read that letter. And she would teach me to stand up and project and talk, and I'll share some of those things with you. So you know what, if you want to get over some of the public speaking fear, join the church, or the local debate club, or the local argument club, whatever you call it. Gives you a chance to stand up and rehearse your talking. It's a learnable skill. It's a skill you can learn. Okay. Setting, this is where I define the setting in the story, is what content is going to be in your slides. Okay. Rather than the setting where your research story took place, which could be, it's up to you, you can define it that way. But I want to use this as a segue to explain to you whether you put math or not. And people tell you it depends on your audience. Who is your audience, right? So this is typically what you would consider if you're giving a talk to a bunch of scientists or mathematicians. You identify your audience. I say that this is nonsense. You got to identify your intent, not your audience. Okay, what is your intent? Are you teaching a method, a technique that requires a lot of mathematics, that requires a lot of fine details? Or are you sharing your discovery with the world? So to math or not to math depends on your intent, not the audience. Because you should be able to take any audience and either teach them your math or share your discovery with them. So for my class, my intent is to teach. I have a lot of math and equations. For research, my intent is discovery, to share with them the beautiful things that we've discovered. There will be equations in here as well, but specifically over here, don't overdo the equations. And for every equation that you put up, flirt with that equation. Make that equation its own person so that they can relate to it and reuse that equation over and over again. Okay, I would love to give you examples, but we're running short on time. But you get the idea. Put a couple of equations, but explain them, talk to the audience about them, expose them to the nomenclature, flirt with the equation, and then keep reusing it. And only pick the salient features. If you made a change to a coefficient, say after you've explained that coefficient and they know what that equation is, then say, we're going to modify this a little bit. And you don't have to go into the details. It's the discovery that matters. Conflict, this is the problem that you are trying to solve. Now, the best thing that you could do to motivate people to comprehend and love the problem that you're trying to solve is to do something extreme when you present the problem to them, something that will stick in their brain. And neuroscience research has proven over and over again that we are more likely to retain information that evokes emotions in us, whether positive or negative, but extreme emotions. So I'll show you an example of what I showed to my class when I was teaching them about round-off errors. I'm not sure you can hear the internal audio. All right. So what I've shown them here is a very motivating example of something that is very scary that happened, something that's very upsetting that happened due to round-off errors. And I bet you they're not going to forget round-off errors for the rest of their lives. There are other, even more, you know, negative movies on that topic, but there are also positive things. For example, when I'm telling them about CFD, for example, I show them how an airplane is designed, but I pick a problem, I pick something that kind of hooks them, or like, it evokes a lot of emotion. All right. So the next piece of the puzzle in telling a story is the plot, and this is going to be the content of your slides. Tell us about the methods used to solve the problem. I usually like to do it chronologically, like think about my Abravanel Hall talk. I started with the email from Professor Pershing, and then we went down, and then we did the initial simulations, and then, oh, it didn't work. What do we think? What are we going to do now? And then, just proceed chronologically. It will keep the audience hooked. It's hard to keep someone hooked for 10 minutes. Imagine trying to keep them hooked for 30 or 45 minutes. Now I'm trying to keep you hooked, and I hope I'm, meeting my guidelines. All right. Now, what I find fascinating in talks is to add a plot twist. So if you look at the attention versus time curve, initially people are interested in what you're talking about, and then they get disillusioned about 10 minutes into the talk. So what do you do there? You either engage them with something like I did earlier, ask you to write a question, etc., or you add a plot twist. and say like, oh, okay, something happened over here. What are we gonna do? Okay, so with the plot twist with Abravanel Hall, we dealt with, okay, we didn't work with us for us with closed doors. What are we gonna do now? We do this, we think of that, we thought of the smoke analogy, blah blah blah. Okay, now again, in my talks, I like to use the inductive method. So essentially lead them along the way with the thought process, because they're more likely to stay tuned because there's this suspense. One of the best things in storytelling is suspense. If I tell you the punchline, or the details, sorry, not the punchline, but just the no suspense, you're not going to be engaged. You're not going to be wanting to listen to know what happened next. Finally, conflict resolution is explaining your solution to us. I mean, that becomes, that's not as important as the storytelling itself. It's like what James Sutherland says about a PhD. It's the journey that matters, not the end dissertation. Okay. Now, here are some techniques, some what they call soft skills that are hard to come by from the masters. So I love to listen to Steve Jobs, some of the best public speakers. I listen to a lot of TED Talks. I take note when I see something I like or a method they used, and I try to summarize some of those techniques for you. Okay, first you got to master your stage. And this is one of the tricks I learned to overcome stage fear. Don't look at anyone, look at the horizon. When you're flying an airplane, and I did fly one airplane once, thankfully there was a professional pilot next to me. It was a little Cessna, and I didn't crash it, but he told me, just, you got to keep it level with the horizon. Just adjust your handles to keep it level with the horizon. If you stand and look at the horizon, you're not looking at anyone, you're looking at just the entire stage, although everyone is going to think that you are looking at them. Okay, open your shoulders just like I'm doing right now. Don't slouch, don't be like this. It will feed back. Okay, just stand up, like, just relax, stand up and give a talk, look at the horizon, project your speaking. So open your mouth, don't mumble, you're not talking on the telephone. Okay, project, enunciate, speak, try to just, you want to get the word out there. Okay, you're not repeating this to yourself. Pause. It's very important to pause. And the way I do this, and it comes naturally to you. And think of it like, you're thinking about something, just pause and take a pace and say, okay, now what? This will give the audience room to kind of consider what you've done so far. Typically, after a pause, you can remind them of what you did, and also gives you an idea of how the audience, if the audience is following you or not. So if you pause, do this with your eye, just look at the audience and see if they're moving their heads with you. Then they are like, okay, tell us, please tell us, give us the next thing. Okay, tell us the next thing. It's very important, and they need to be well timed. So don't do 50 pauses. 2 pauses in a 1 hour talk are more than enough usually. Okay. Now, walk, and the next one is gesture. So, I if you've seen me in my walks, I look like a chicken looking for food. I'm like walking everywhere and moving everyone, because the focus is on me, not the slides. I want the focus to be on me. I'm telling the story, and you also better gesture. Okay, so let me give you an example of a recent video I recorded for class. So look at me, how I'm walking and gesturing and moving around. We say use gestures like a true Middle Eastern person would. Okay, we gesture a lot in the Middle East, so use gestures. Okay, all right. So you probably get the idea now from this video. All right, revise. Typically, when you revise, gives the audience, if they were chatting or doing something on the side, gives them a chance to recap if they missed something. I do the revise when I pause. I would pause like this, and I would say, okay, point my finger, tell them, okay, so far we know that the Thomas algorithm works on tridiagonal matrices. Okay, now what if we had a generally sparse matrix? What do we do? So we revised, and now we're going to ask a question. Okay, set the stage, and this could be a plot twist as well. Is key, or simplify complex ideas, and that is, I'm going to spend some time on this slide. And this is one of the hardest, and I struggle with this a lot. And especially when writing proposals, because you kind of don't know the answer and trying to explain things in a way that everyone can understand. But I have two tips for you that will help you simplify your complex ideas. And I'm going to show those two tips here. Avoid jargon and focus on the problem solution, not the features. Avoid jargon. I'll give you an example from my PhD. For my PhD, I used regular and singular perturbation theory to approximate solutions to the Helmholtz equation for Beltrami type fluid flows in porous channels. Huh? Who cares? Filled with jargon. Did you learn anything from this? I might have this discussion with you if we're like doing the solution together. But for someone you're talking to, for your program manager trying to get funding for, what you want to say is, I study fluid flows such as those encountered in rockets or airplanes, and because they're very difficult to describe. My research is focused on finding approximations to these flows, finding approximate solutions or fast ways to understand these flows and describe them. That's enough. Someone asks you, how do you do that? Tell them it is difficult, or tell them it just works. I use a lot of math. All right. Another thing you can fall in the trap of is you get focused on the features, and this is an example from the work that Mokbil is doing. We use high order pressure approximations to eliminate the projection step and high order integrators to the Navier-Stokes equations. We allow the user to specify where a projection can take place. So this is focusing on the little features, the high order and where to use the projection step, and there's jargon. Instead, fluid flow simulations allow us to predict things like the weather and allows us to design complex engineering systems such as airplanes. However, they can be very costly. My work is involved in reducing that cost. And recently, we developed methods that are 50% cheaper than conventional methods. That's enough. Okay. All right. So one other strategy is, if you need to be able to explain it to your grandmother, to someone on the bus, explain it to your kid. Mark asked me the other day, what is air pollution, Poppy? And I told Nancy, go explain. I'm like, you can't tell the kid there's particulate matter and there's this and there's that and there's whatever NOx, etc. You got to be able to explain it. If you can explain it to a child, to your grandma, call your parents, back home, etc., and explain your research to them. That will train you to explain what you're doing. Okay. Now I want you to pull out a pen and paper and give me a complex description of your research and an equivalent simple explanation of your research. So the complex one, say for Elizabeth is, filled with the PCA stuff and the source terms. Camilla, there's machine learning and there's like these neural networks and these manifolds, and drones and coal and pressure projections, etc. Come up with a very complex explanation that's filled with jargon, focuses on the feature, focuses on the jargon, whichever, and then give me an equivalent simple explanation. You got about a minute. All right, I'm gonna call time. Okay, I'm gonna proceed. All right, one other tip is to keep the audience involved. And this is the best thing you could do to put a rod in that attention versus time curve. Every time you see the attention going down, make an activity for the group. Can you do it for in a public speech in an audience? Absolutely, you can. It's harder to do right now online, okay? But I just tried it. I asked you to take a couple of minutes and do something. Okay, now many of our talks are not of this type, but you can pause and ask a question, okay? And tell them to talk with each other, right? Do it. It's okay. It works. Okay, and pause the question and maybe answer yourself. Now, I know early on it might be kind of weird for a PhD student coming to present their dissertation and asking a question, but overall, you're going to be you're going to start doing public talks more and more, and you better. Okay. Now, here's one very important thing I like to tell. I like to do, and I like to tell my students as well, and is that if you cannot tell your story without visual aids, then your story is not worth telling the way you are telling it. In other words, any talk you're preparing, you gotta be able to deliver it without visual aids. And Hayden tried this quite a bit for one of his recent talks. And I asked him just rehearse it like when you're driving or taking a shower or on the telephone with someone, just call someone and talk to them about it. Do it without visual aids. It can be done. Okay, and then the visual aids will be something extra, but the visual aids should not be the driver of your talk. Okay. And my tip of the week, I know Hong has a tip of the week, but my tip of the week is this. If you've ever wondered what this stupid little arrow on your gas dial on your car is, this arrow points in the direction where your gas cap is. I always was confused, like, where is my gas cap? And then I noticed this arrow. I was like, interesting, So I looked at the cars in our driveway and my friend's cars. They all had the same arrow until I found a car with an arrow on the other direction. I looked, the cap was in the other direction. Now I realized I could have probably Googled this, and I did Google it. And indeed, that's what manufacturers use to indicate where the gas tank is. All right. With this, I will end the talk on the live stream, and we are going to switch back to Zoom right now. Thank you so much for your kind attention.